A bit of a provocative title, but it got you all in the room. So success. I'm here to talk about my favorite thing in the world, which is distributed traces, and specifically about one area that doesn't get a lot of love, which is sampling. So we are going to go on a little bit of a brief historical journey to figure out how we got to where we are today, because this is most folks' experience with tracing, right? You are sold this beautiful vision of this rich data set that your engineers are just going to solve the incidents right when they come up, right? And maybe you get some auto instrumentation rolled out, you're kind of ignoring those expensive bills, but developers are saying, I tried to use it, but I just didn't find anything valuable there. I'm going to go back to what's tried and true with metrics and logs. And who can blame them? Because we've all got jobs to do at the end of the day. We need to resolve those incidents, mitigate issues, so on and so forth. And really, this low usage doesn't surface as a huge problem until really you get an expensive bill, and all of a sudden leadership is saying, please justify why we should spend so much money on traces when 2 people use it across the org, the 2 people that sold us this beautiful fantasy. So I want to save you from that. I want to save you from turning off tracing, because tracing is one of the most exquisite types of telemetry we have today. And we're not going to go over the full history, but tracing's not new. Our story starts 2010 with that Google Dapper paper. And in the same time span that tracing has been alive and a concept, I have graduated from high school, college, and pivoted to my 2 of 3 careers. So like, tracing is not new, but why do we still struggle with it? Why is it not table stakes telemetry for most orgs? And back in the day, before 2019, when you saw that exciting OpenTelemetry logo up there going GA, until then, there was like 7 years that we had competing tracing instrumentation standards. This made it difficult for early adopters to decide who to go with. It made it difficult for us observability vendors to say, which one do we want to support? And it made it difficult to have sort of this cohesive instrumentation within the tracing world. And I think that was totally fine. I think we needed to muddle through and have lots of different ideas and approaches for this new type of telemetry. However, I'm very happy we've coalesced on one. The second piece was that tracing as a function or capability of an org was pretty immature. You couldn't find a lot of other organizations that were doing tracing, so it was hard to ask for guidance, advice, swapping configs, let alone trying to hire folks to run tracing teams and evangelize it within a company. And finally, tracing came and comes with a pretty steep learning curve as far as getting the right level of instrumentation, and as well as using traces actually in analysis and exploring your system. So that was then. What about now? Things look a little better. We have OpenTelemetry. The cloud vendors, the observability vendors, the community came together. We picked one. We did it. And so now, today, there is a true standard. So we can't say that that is a trouble anymore. We also can't quite say that tracing is immature. Tracing within OpenTelemetry has been GA for 4 years. Like, it could almost go to kindergarten. This is not the new kid on the block anymore. But in my opinion, the most troubling trouble with tracing is this steep learning curve. That could be a whole talk on itself. I could talk about tracing all day and all night. But I had to scope this talk down to one topic, which is sampling. So when we think about sampling, we're kind of looking at the true cost of tracing. There's a couple different dimensions of cost to consider, both computationally, what it takes to generate and send those spans, which turn into traces, as well as the financial cost to your company, whether or not you're self-hosting or using a vendor, that financial cost to store them and all of those sending across the network. So one level deeper, your applications are going to have a cost to generate and send those spans. Your collector, which in this specific instance, I'm talking about whatever observability pipeline or generic collector or vendor collector you've got, will need to ingest spans, potentially process, export, and then, of course, onto storage. Later, I will specifically talk about the OpenTelemetry collector, but in this case, any collector component. when we look at the cost, the levers, what makes tracing expensive, what makes it so variable, what makes it tricky to predict? Well, the more requests you have running through your system, the higher the throughput, the more traces generated or potential traces generated. The percentage of instrumentation across your system. Of course, the more apps that have tracing instrumentation turned on, that is more spans, which is either bigger traces or just lots of traces. And then metadata, which can get heavy, whatever you're throwing on there for labels, span events, logs, all sorts of things. The bigger the spans, the bigger the cost to send, and the bigger the cost to store. So, hearkening back to our early 2010 Dapper paper, quote, in practice, sampling rates can be as low as 0.01%. That's kind of wild. It kind of sounds scary that you've been sold that tracing is this beautiful, rich data type, and now we're going to throw 99.99% of it out the window. Why do we sample, and what does it mean to sample? Really, it's considering the value of the resulting trace data set against the cost of creation and storage. So we'll talk sampling. Think about it like you're panning for gold. You're dipping into this stream of requests. You're getting rid of the sediment, the stuff that doesn't matter, and you're getting those golden nugget traces that show you interesting things about your system. This is possibly the naming inspiration behind the Sifter paper, which came out in 2019. I love tracing so much I was reading academic papers, which if you know me, that is a wild, wild concept. But what I found as a generic takeaway that I think will serve everyone well is how the authors of the Sifter and later Hindsight paper frame sampling decisions. They think about it as 3 questions. What traces should we keep? What traces should we toss in the trash? And what makes an interesting trace? And these kind of sound like variations on the same thing, like are those not just 3 ways of asking the same question? But the way that you answer each of them specifically can directly translate into a different sampling policy. But we will double click on what makes an interesting trace. Because at the end of the day, traces are valuable when we're using them to explore and understand our system. And they're not valuable when they're just taking up storage space and nobody's looking at them. So what's an interesting trace? The authors of the Sifter paper broke it down into infrequent request types, that is, kind of rarely executed code paths within your system. Anomalous events, things that happen out of the ordinary that you probably want to double check and look at. And then our edge cases, which of course, in this room, we're pretty familiar with errors and tail latency. So that kind of constitutes what an interesting trace is. And when, again, we're making these sampling decisions, we want to save the things that are interesting because that is going to be higher value for both of our costs. So let's bring it down to earth with an example. Thinking about the most common thing in the world these days, buying something online. From a user's perspective, they're like, oh my God, I love this cat sweater, like I need it yesterday. And to them, you click one button for checkout, and boom, the cat sweater's yours, it's on the way, everybody's happy. We know in this room there's probably a few more requests that were needed to fulfill that. And so in our very small and trivial example, we're going to look at 3 services fulfilling this checkout request. So first, our cart service is going to get that checkout request. We then need to reserve the items. Once the items are reserved, we can then go ahead and say, yep, we will charge you for this. We've got it on reserve. Once we've got your money, everything's good to go. We'll return right back to the user. And that's great. That's in the real world, there's going to probably be a few more hops there, but this is the example we'll use going forward. So now we can talk about how spans become a trace, and we will look at this from the collector's point of view. I want to break this down. I know many folks in this room are probably familiar with this process, but it's really important to have a strong foundation in understanding how spans become a trace so that you understand how your sampling decisions affect the end data set that you get sampled. So from the collector's point of view, cart service gets that request to checkout. You can kind of think of like a high school track coach like sitting there starting a timer. He's got his timer started. We've got a span ID. We've got a trace ID. That span is staying open. while we make our request to inventory service. We got another little high school track coach. We're going to start our span. We've got a parent ID pointing back to our cart service span. We've got our own span ID, and we're sharing a trace ID. Cool, cool. We do our work. Items are reserved. And at this point, once we've returned to cart service, we are free to send that span to the collector. So from the collector's point of view, the first span in this trace we're getting is span number 2. Span number 1 still being held open. We're not done fulfilling this request. And similarly, we're going to make our call to the payment service. We get our own unique span ID. We share the parent ID because, again, cart service still called us. That span still called us. And then we share that trace ID. Everything's great. We charge the card. We send our span. So collector has gotten span number 2, and it's gotten span number 3. And we finally complete to the user, you've got the cat sweater, and then span number 1 hits the collector. So how do spans become a trace? Well, you've got to wait for all of the work to be done. Then at that point, once you've got all the pieces, all the spans together, you know the relationships between them, you know the temporal ordering, that is how you get a trace. A trace is not like an innate data type. It is something we assemble from spans. And you're probably most familiar with looking at traces through a trace waterfall. So of course, to us as the engineer, we want the whole story kind of in the right order. We don't want it in span 2, span 3, span 1. This is how we kind of take a look. And like a tiny, why tracing? I think if you're here, you're interested in it. But it would make a really big difference if inventory service was taking up most of the time to fulfill this request versus payment service. Maybe payment service is a third party like bank or something, and maybe they blew their SLA with you, and it would matter which part of this request was taking the longest if somebody started complaining about long checkout times. Traces are beautiful. We love them. So let's talk about sampling them. Heads or tails. And we will start with constant sampling. So this is your on-off light switch. This is sample everything 100%, always on, or always off, sample nothing. Sometimes you would want to sample everything, maybe when you're doing local development or in a lower environment or for specific time-boxed use cases. But on the whole, I don't know that folks recommend constant sampling in prod. Cool. So head-based sampling. This is when we're making our decision at the head or the top of the request. It is kind of a deceptive term because it suggests that at this point, you're choosing between traces of what to keep and what to toss, but that is kind of a lie, right? Because at the point of the checkout, the initial checkout request, we are making a decision about a trace to be, not a trace that exists. But this is the terminology we have, so head sampling stays. If we look at our example, like I said, cart service gets that initial checkout. We have no idea how long this request will take. We don't know if there's going to be errors. We don't know if there'll be errors that are on our side internally to inventory or externally with our payment service. But we've just got to make this decision because this is head-based sampling. How? What are implementations? How do we do this? How do you make that decision? It feels a little silly. It feels a little interesting to make that right at the head. There's a few approaches. We'll go from most naive to kind of most sophisticated. So probabilistic is essentially, you can think of a sampling policy like sample 1% of all traces. This is configured in the SDK. And when I'm talking about the implementations, I am specifically referencing OpenTelemetry, the OpenTelemetry collectors, as well as Jaeger. But yeah, sample 1% of traces, and you would pass in some sort of decimal amount that you want. Great, probabilistic. Then we've got rate limiting. Sample up to 10 traces a second. That would be an example policy there. As far as I did my research, there was nothing out of the box with OTel that would let you do rate limiting. So you do need to bring in the Jaeger remote sampling extension. So OTel traces sampler, gonna set parent-based Jaeger remote, and then pass in some arguments with an initial sampling rate and how long you want to be polling for. That's rate limiting. And our most sophisticated is adaptive. This is where you could set a policy like sample 1 trace per second per endpoint, configured both in the SDK and the collector. And a note on this parent-based, what is this parent-based thing? That is a decorator that says, make sure when you make the sampling decision, when cart service says yes or no, keep or toss, that you tell everybody else in the request chain what the decision was, so we're not wasting, we're not creating spans that were already marked to be, that shouldn't have even existed in the first place, according to our sampling policy. Great. So our trade-offs really with head sampling is the predictability of the volume, which could be a rough proxy for cost, versus the interestingness of the trace data set. Head sampling is really efficient for high throughput systems. There's some level of scale that your apps could be operating at where it's not feasible to send and generate and send 100% of your spans through. You really want to think about head sampling more as limiting data generation versus creating interesting traces or saving interesting traces. It's fairly easy to reason about, which is a plus, with the exception of adaptive sampling, which is going to be a shifting sampling rate over time. And it's a pretty simple setup. So that's what head sampling's got going for it. The big drawback is that it can sacrifice interesting or edge case traces, specifically if they're rare or intermittent. Those, if they're going to be sampled at the same probability as like 500 successes or health checks, that might be sampled. You may not get that sampled, and it may not be in your data set. And this is when you get engineers saying, like, I tried to use tracing, but nothing of interest was there. Cool. And in contrast, of course, would be tail-based sampling, where we're making the sampling decision at the very end, once all of our services have generated the spans, once we know what happened. We have all sorts of interesting factors and metadata we can bring into our sampling decision when we do it at the collector level. So many, in fact, we're not actually even going to be able to talk about all of them or the endless ways in which you can combine them. I'm going to pull out the top 3 uses that I see, but I do want to call out our old friends from head-based sampling. Probability and rate limiting are available in the OpenTelemetry tail sampling processor. And it is still great to apply probability sampling and rate limiting sampling at the collector level. It is probably good to protect yourself there. But you would still be getting and incurring the overhead of your apps generating and sending those spans, as well as the collector to ingest them. So something to think about. All right, so what would a tail-based sampling policy look like around latency? This is where you could say sample all traces to the checkout endpoint, where latency is over 2 minutes. If you work in e-com, you know that 2 minutes or 2 minutes, 25 seconds is sort of like the threshold users have before they just like jump ship and buy from your competitor. So you'd probably really care about things that happened that took longer than 2 minutes. And in this case, this is where we see the powerful like compositing with tail-based sampling. So you would say, it's an and policy, make sure you're matching on cart service name, do a little regex, find your route, and then set your latency threshold milliseconds. This is not obviously code complete. I wanted to communicate the ideas behind sampling policies there. But the OTel docs have a very, very good example config to look at. Great. We also probably care about errors. We care about when things go wrong. So this would be another and policy where you would match on service name, match on route, and use status code. And note, like this is not an HTTP status code. This is the status code of the trace overall. So any span along the way that experienced an error could mark the trace as having an error, and so you would maybe want to save that. And again, it's really great that we're able to target here both a route that we care about and a service. Great, and kind of to sum up the rest of all of the options we had there is attribute-based. So this is where it gets really interesting, and it's about the more you put into your instrumentation, the more custom metadata that's specific to your domain and your business, the more powerful your sampling can be at the end of the day. So for our cart service example, we'd say sample all traces on checkout where the cart value is over $1,000. Maybe we really care about the big spenders on our site. So in that case, we just pull out a numeric attribute, and that's kind of up to you, whatever you've got available. In our case, cart.total, minimum value of 1,000. That's Pretty powerful stuff. What are our trade-offs associated with tail-based sampling? Of course, our benefits. It's focused on capturing interesting traces, traces we care about, situations that we're going to be interested in. And it's got a highly flexible configuration. Drawbacks, there's a few. It's inherently higher cost, both computationally and financially. Of course, you're going to have all your services generating those spans, sending those spans. You have more variability and unpredictability there. The more requests you get, the more traces you have to generate and store. And it may introduce some latency depending on how complex the sampling decisions that you're having the sampler make. So these are things that you want to keep in mind. But what if we combined them? It doesn't have to be a versus. It doesn't need to be one or the other. We could say, get our checkout request to cart service. We could make a sampling decision. We say yes. The work continues. And then once we get to the collector, we could say, hey, let's make another sampling decision. Let's narrow this down. Let's sift through to the things that we really, really care about, while knowing we're protected with that head-based sampling up there, that we're not going to tip over our fleet of collectors or run up the bill. So I think it's all good and fine to talk through sort of example scenarios, or here's the high-level definitions, but let's put you in the driver's seat. Congrats, you are now Prada's chief SRE, and it's Cat Fashion Week. And you're dropping a new cat sweater every night, and everyone's going bananas for it. Yesterday's drop sold out in about 20 minutes. And unfortunately, when you rolled into work, the PR team said that a famous cat celebrity was complaining very publicly that there was a long checkout time, and that has hurt our brand perception, so you better fix it by tonight. Not only that, but customer success has many confirmed reports of failed payments, people who were attempting to buy who couldn't, and then the drop sold out. We've got a lot of angry customers on our hands. So while the business made the money it could have, everything sold out in a relatively quick amount of time, the people aren't happy. And we need to make sure today is going to go well. So we're going to look at this 20-minute time window of traces. And we're going to compare different sampling strategies, and you're going to decide which one you hoped would have been chosen for you to effectively investigate these issues. So we've got our 20-minute time span. You've identified a 5-minute period where you saw that there was long checkout. P99 shot up to 3 minutes on that checkout endpoint. And you found a 10-minute window where you totally saw the error rate go up to 3%. We don't have to remember those numbers. We've got some pictures. So we'll start with constant sampling. Volume-wise, in that 20 minutes, we're going to assume, for nice mathematical sake, that you're going to have a constant request rate of 500 requests a second. That makes the math work out nicely for me. And the point of this is to do a comparison of the trace sampling strategies. So in that time span, we generate 600,000 requests and 600,000 traces, and 600,000 traces get stored. Pretty simple. Now let's look at this with the lens of interestingness. And I'm going to define interestingness as the ratio of traces that we care about that have those errors and have those latencies, those are the issues we need to chase down, to success. Because there are a few ways for things to go right, but many ways for things to go wrong. So we would rather have more of the errors and the high latency and just a little bit of the success so that we've got some comparison. So in this case, for constant sampling, 590 some odd thousand success to just 9,000 errors and just 1,500 high latency traces. Let's see what happens to this interestingness when we move to head-based. And so just as a comparison, send everything, keep everything. This is our resulting trace data set. If we were to have a head sampling policy at 1% probabilistically, our 600,000 initial requests drop down to 6,000. That's a pretty big drop in volume there, and then that 6,000 is all that we store. Cool. How does the interestingness go? Oof. Not even as good as the constant sampling, really. We drop down to about 5,800 success, 90 errors, and 15 high latency traces. But really, we're looking at kind of that ratio of the green to the red and the yellow. And we see that there's a ton of successes that are frankly not that interesting to us for this particular investigation. So here's our little comparison. You see the big drop in volume, but the not great interestingness ratio. Now for a tail sampling policy at 1% of successes, 100% of errors, and 100% of our high latency, we are going to start with our 600,000. We still generate 600,000 traces. All that has to get to the collector so we can make our decision. And we end up storing 16,395 traces, so more than we did with head sampling. But does it pay off for us on interestingness? Yes, look at this, look at this. We got a little bit of green, but we got a lot of red and yellow. So of that 16,000 some odd that we're saving, we still got that 5,800 of success. We've got all of our 9,000 errors and all of our beautiful 1,500 high latency traces. So we got more volume, but way high on the interestingness scale with our tail-based sampling. And this is just for comparison purposes, volume versus interestingness. Where it gets interesting, and where I was honestly pretty surprised working through this napkin math example, is when we combine them. So if we take our same tail sampling policy, our same 1% at the head, what does this look like volumetrically? Well, our 600,000, again, drops down. We throw out 99% of those to 6,000. But when we apply our tail sampling policies, we end up storing 164 traces. That's teeny, 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 tiny. We better hope that those are interesting. And they are. From here, we've got 59 successes, 90 errors, 15 high latency. And look at our ratio. Look at this beautiful, we've got so much interesting versus a little bit of success, just that we need for that comparison purposes. And here's the side-by-side comparison of those. So if this were you, and you had 6 hours left in your workday, you had to sort through all of these traces, try and find out where things were going wrong, then figure out why things were going wrong, which one would you choose? Would you choose no sample? You got everything, 600,000. Would you choose tail-based, where you've got a pretty big size of a trace population, 16,000, but kind of pretty good on the interestingness, but more volume? You got head at one, and then you got your head and tail. And you can see head and tail, you've really got the interestingness turned up, even though you only have 164 traces kind of at your disposal there. And the real answer is, well, it kind of depends. It depends on what Prada's budget is. It depends on how you have scaling for your collector setup. There are a lot of factors that come into play when making sampling decisions. And I would say, I would want to spend most of my sampling budget during Cat Fashion Week, when it really matters, when all eyes are on us. Maybe for the rest of the year, turn it down. So we can start to think of sampling as sort of an active decision that you're making that doesn't need to be the static global policy, 1% for everything. No, 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 please target, go by service, go by route. It doesn't need to be this all or nothing approach with sampling. Other things that might come into play, what if your company was an e-commerce platform like a Shopify or an Etsy, where your traces represented different shops, different customers, versus if you were Prada retail, when all of your traces represented individual customer interactions. Again, yeah, what if it was holiday shopping season when you're making 90% of your annual revenue? What if your company was about to launch a mobile shopping app? You might want to turn way up the sample volume for traces that originate from your mobile app. Or what if you were told to cut the observability budget by 30%? That would be sad, but you have a lot of levers at your disposal when it comes to sampling. You don't have to throw away 100% of your traces. So what are some gotchas that come in here? I don't want to sell you on traces are beautiful, they're perfect, go forth and use them, you'll never run into a problem. No, no. As mentioned, I think one of the first mistakes that people do is set it and forget it sampling. I think that's also true for setting alerts. I don't trust an alert that hasn't been tuned or touched in the last year or so. And same with your sampling rates. Your business priorities change over time, your system changes over time, the people using it, as well as the services kind of coming in and out. So when you just set your sampling rate and you kind of walk away and don't revisit it, you may have a lot of volume and low interestingness. So think about ways that you can bring sampling decisions to the forefront as you're doing big launches, as big business events are coming up. Think through when and where you would want that. Another thing is siloing your telemetry. Please don't do this. There's a couple ways that you can link your traces, because traces on their own, often you'll get alerted by a metric. It'd be great to go to a trace, and once you know the where, you want to maybe check out the logs for that particular component to see the why. So traces kind of sit in the middle of this exploration. So the ways you can link your metrics to your traces are called exemplars. That's where for a given, like if you're looking at a metric chart, you're like, wow, what is happening with these long checkout times? Let me click on that and then go to a trace that's representative of that like super long checkout time. That's awesome. That is not having to go through a bunch of tabs and figure out timestamps and stuff. So please, link your metrics and traces. You can also link your traces to your logs, where you can inject your trace IDs and span IDs. So once you've narrowed down the where, you want to know the why, it's great to be able to just hop to the logs associated with a particular trace. Because as much as I love tracing, all of the telemetry, it's very powerful when it works together, and we should not be keeping these things distinct. And finally, I think a big gotcha is to only have sampling as your only shaping strategy. And what do I mean by that? What do we mean about shaping? Well, a lot of folks get introduced to tracing by flipping on auto instrumentation, and they get a lot of data, not all of which they need. Specifically, I think about like a bunch of labels that get emitted that you don't care about and you weren't ever going to filter by. I think in addition to sampling, if you look at things like dropping attributes you don't care about, filtering them down, combining them, think about other ways that you can kind of trim and shape that data so that it's useful for you. You don't have to throw everything away. OK, so what does tomorrow's tracing look like? We've covered the tracing of we've covered some of the issues with tracing. We've covered how you can sample to get to kind of optimize the data volume for what you've got in your budget, for the interestingness, the value that it'll bring to your engineers. What does it look like tomorrow? Well, I want you to walk away from this talk, if you were to condense it down into like one nugget of information. Head-based sampling is like taking a chainsaw to lop off a branch. And tail-based sampling is when you take that branch, you take it into the wood shop, and you kind of finally carve away the things you care about and get rid of the stuff that you don't. I think it was called a chisel. I literally just started carpentry, so someone can tell me afterwards. But I think when I think about the value of tracing, and I think about selling people on tracing, and I think about all of the failed tracing strategies and implementations at companies where it's going to be really hard to convince people to pick back up tracing, I always think about this Uber engineering quote from that blog in 2017. Tracing made queries like find me requests where the user was logged in. The request took more than 2 seconds. Only certain databases were used. And a transaction was held open for more than 500 milliseconds. Possible. Tracing made the impossible possible. I was very, very lucky to be introduced to tracing as a little baby SWE, and it totally changed the way that I explored unfamiliar services and the relationships between services in a very big distributed system that I could not have ever kept all in my head. I want everybody to have the power of troubleshooting with tracing at their disposal, and that is why I really wanted to give this talk to say, hey, if your tracing initiative is struggling or it's stalled, and you're feeling the budgetary pressures to just get rid of it because people know what to do with metrics and logs, think about sampling. Think about the ways that you can educate not only your engineering leaders, but finance and software engineers, all about the ways and the levers that you have to make the best choices, the most optimal sampling strategy for your system in your context. And with that, you can find me around the web at PagerDuty with an I. I've got a blog. I'm pretty active on Mastodon. You can email me at Chronosphere and LinkedIn as well.